Hello everyone. In the previous chapters, we saw how to insert an image or a video in our montage, and how to put it in the format we want, as well as how to take the part that interests us. Now is the time to start animating, because PTE is intended for this. So let's open our program, and add an empty thumbnail. Leave its default time, and, in the menu, configure the view. In the tab Transitions, use the style Instantaneous Transition Cut, located in the Basic Transitions. I intentionally changed the transition, so that when you preview your edit, it starts at the beginning, without a fade out from black, preventing us from seeing the full duration of the view. Now open the Objects and Animations editor. This done, add an image, any image, and of any format. In order to have an identical result, frame it in 4/3 format, and, as a reminder and exercise, be sure to take the part that is interesting, that was the subject of the previous chapter. If everything is correct, your image should perfectly match the top and bottom edges, and there should be space to its left and right. Let's start with the basics. Let's go to the tab Animations. You should know that the displacements are expressed by default in percentage. This is fine, because if you use the displacement in pixels, it could be different depending on the size of your image, or its support. Yes, but, in percentage of what? This is very important. The displacements of all objects are calculated in percentage of the object on which it depends. All the elements placed directly in the list of elements therefore depend on the fictitious frame whose size is exactly that of your view, whatever its format and resolution. We'll come back to that. Each element is also placed very exactly in the center of the so-called parent object. How? Parent? And children too. And yes, let's explain that. First we have our dummy frame fitted to the view. It will be the parent of all the elements that we will place in our timeline, and all these elements will be its children. The main fictional frame is immutable, and it will be impossible for us to modify its size, position or rotation. Now, our image has been placed in the center of our view, to match these criteria. I told you that the displacement was expressed as a percentage, yes, exactly, as a percentage of the distance between the center and the edges of the frame of which it is the child. So, in order, the horizontal displacement, also called x-axis, is 0 to -100% for displacement to the left, and from 0 to +100% for moving to the right, which gives a total displacement of 200% from edge to edge. The vertical displacement, or the y-axis, is the same, being from 0 to -100% for the downward displacement, and from 0 to +100% for the displacement upwards, and therefore also 200% for moving from side to side. If we only work in 2D mode, it could suit us perfectly, but PTE can work in real 3D mode, so that could cause us a little problem, because the displacement ratios are not identical, and we would then have to calculate the ratio between the displacements x and y to have animations correct. Fortunately, this will not be the case thanks to the addition of frames, which will compensate for this. As I just said, PTE works in 3D, and that's why you have a third displacement value, the z-axis, which corresponds to the displacement in depth. Attention, this is very important. This displacement being in 3D, it simulates the real displacement, and not the size of the object. which means that at 0%, our object will be located in the center of the virtual space, and therefore, if we don't change its size, it will cover our view without overflowing. The positive displacement will move our element to the rear of the view. At 100%, it will not be reduced to a size of 0%, but moving backwards by the same ratio as that of the parent size. Similarly, if you give a negative displacement, then it will be moved forward. A very important observation: the distance between the center point of the view and the camera generating the view, for a 100% size of the element, is 343%. Which means that, moving beyond -342% will make your object invisible, because it will then be virtually behind the camera. This distance is modified in proportion to the size of the element's parent. Now, as I told you before, we can overcome the size ratio problem x, y, and z. We are going to use an element of type frame. A frame is an empty element, invisible in the final cut, which allows you to animate or to attach various elements or objects between them. Already, this will allow us to animate complex objects on a single element, avoiding a good number of animation keys, but, moreover, depending on the size that we give it, to move its elements, children, in proportion to its size, and not to that of our assembly. Let's see this. Add a frame to your montage, basic, and by default, our frame is in Full HD format, that is, 1920 by 1080 pixels, therefore, in 16 nits. It therefore perfectly covers our view, and it is represented by its border, the yellow frame, and displays its center, the small yellow circle in the center of your view. In the tab Properties, we will make it square. The fourth line, original size, must display the values 1920 by 1080. Modify these so that they are identical, for example, 1080 by 1080. Now you'll notice that the frame is perfectly square, and its top and bottom edges match the top and bottom edges of your view. Let's go back to the Animation tab and select your image. For the first key, that is at time 0, enter the value -100 on the axis of movement X. Then place your time at the end of the view. Add a new key at this moment. Then, activate the commands move and enter the value 100 at the X-axis. Now, play your animation, and, over time, we should see our image scroll from left to right, starting from its right half and ending at its left half. We will now link our image to our frame. To do this, right-click on its name in the list of elements, then click on Cut. By using the function Cut, I delete my image, but I also make a copy of it, unlike the command Delete, which deletes the image, but without making a copy of it. Now, right-click on the frame, then use the command Paste. Your image has been recreated, but this time it is attached to the frame, of which it becomes the child. We will see later, in more detail, this parent-child relationship, and the display of it in the list of elements. In short, now our image therefore depends on the frame, which is square to it, and, you must also have noticed, that your image has been resized to be adjusted to the size of the frame, and therefore, his position is different. Replay your animation. Indeed, the animation no longer starts in the center of the frame, but we see, more or less, 3/4 of it, which is also the case at the end. Why? because the percentage of displacement of the image depends on the size of the frame to which it is attached, and therefore, at -100%, the center of our image will be moved to the left edge of the frame, and not more, to that of our screen. So, now, the actual displacements in X and in Y have an identical ratio, thanks to the square shape of our frame. The same goes for the Z-axis. So here is in our simple example, one of the uses of a frame in our montages. Personally, I always advise, when creating a view with 3D, to first create a square frame, which I name master, to which I attach all the other elements. You will also see later that this frame will also be used by us to simulate movement in our view, as if we were moving in our scene. You will also see that linking elements together is not only done on a single level, but thanks to this we will be able to create very complex animations, without necessarily a lot scholarly calculations, but just a bit of logic. In our next chapter, we'll put all of this into practice, with the creation and animation of a carousel photo montage. Thank you for your attention, and see you soon in the rest of our tutorials dedicated to PTE. Katerina and Patrick.